Hello everyone and welcome to this video. First, let me introduce myself. I am Utkarsh Gopal Bhattaria. I am pursuing my BE degree from BITS Pilani Hyderabad campus and I am entering my third year. Now let me set up the context for this video. In this video, we are going to take a dive into the code base for Tiproot, explaining the architecture and how everything is set up. There are primarily two reasons for recording this video. The first one is that I am still learning a lot of things and I'm new to this. So any experienced developer would give me insights into it. And the second reason is to set a base or to set a understanding of the code base for contributors if someone would like to contribute to my project. Okay, so let's get started. So let's start with cloning the repo and then we'll work along with that. So I'll attach the repo link in the description or you can view it from my profile. Desktop, zoom into this. Hey, this is me from the future. While editing the video, I saw that I could not explain the architecture, so I'm doing this part here. So let me explain the entire life cycle. So the client, as soon as they open the tipping page, they send a get request to slash API slash streams, which returns a response containing the name of the streamer, the goal title, completed or not, and the UPI link. And when they click on create tip, they send a post request to the tips API, which reports to the ingestion microservice. And the ingestion microservice writes the tip data to the database. Now I will go on the database schema in just a minute. So now the client has successfully created a tip, but in order to complete it, they need to perform the payment. So we go ahead and scan the QR code, which pops up as a notification on the streamer's phone. Our app listens to that notification and sends it as a post request to the webhook API, which also responds to the ingestion server. Now here the ingestion server does two things. It checks for the bearer token, and if it is valid, then it performs a profanity check. And based on the profanity check, it updates is NSFW or it's not an NSFW. And with that, the data is published to the NATS JetStream on the event tips.processed. Now all our API, rest of the microservices, moderation, OBS engine, stats worker, dash updates, and front-end SEC all listen to the events tip.processed. Our microservice frontend.sec is responsible for showing the payment status on the client side. So as soon as it gets the tips.processed, it sends a success message to the client. It holds an SSC connection so that the connection never drops. Then on the OBS side, the OBS client tunes in or subscribe to the URL, and the OBS engine publishes to the URL. This also happens via SSC connection. So as soon as a tip is processed and it is not profane or it is not NSFW, it is sent to the OBS engine. The OBS engine then forwards it to the OBS client. Now, in case of a profane or an NSFW tip, then uh, the OBS engine drops the tip from showing onto the screen, and the moderation microservice steps in. The moderation microservice then responds to the streamer dashboard as well as to Discord, sending the content of the message. Now to the streamer dashboard. Now we have the dash updates sending the continuous SSC updates to the streamer dashboard. These updates include an update in the goal or an update or just a tip. So this dash updates microservice forms a constant SSC connection with the streamer dashboard and shows whatever tips are sent to the OBS. Now to mimic a WebSocket, we are using a dash updates, but it can only send data from server to the client. So to mimic the WebSocket, we use a post request to send the data from client to the server. We use a post request. This post request is sent to the moderation microservice, Now we have two options. We can click on a tick that shows the notification on the screen, or we can do a cross that does not show the notification on the screen. And this is the authentication cycle using standard OAuth. It sends a GET request to our authentication, and then it redirects it to Discord. Then Discord sends an access token to our backend, and at the same time redirects our streamer to our callback URL. And the contact is microservice is completely different because it handles something that is not related to all of this. Now let's get to the database schema. The database schema is pretty simple. For active sessions, we need to have a refresh token. So this is where we store them. We have the ID, we have the streamer ID, we have the refresh token, and the time they are created at, so that we can set a TTL. Then we have blacklisted tokens. You simply have a token and the created at time. We have pending signups for signups that do not enter the master password. So we have their Discord ID, we have their display name, we have their email, and the time they created it. Then we have a table. Now these two tables are linked directly to our ingestion API. The streamers table holds ID, Discord ID, display name, their email, their UPI ID, the overlay token is used for their OBS stream as well as for their app as well. Then we have a created at, and we have the support title, support total, support completed, and the live link. For tips, we have the ID, we have streamer ID, we have the client key, we have name, we have message, the amount, the status, created at is NSFW or not, request ID, and support key. Now for the table streamers and tips, I have created a read replica. So every time we do a write request onto these, it is fast, but the read is even faster with read replicas. Also, this is my first time recording a video and explaining Codebase to someone else. So I think there is a big scope that I would miss a lot of things, or I would not be able to explain a lot of things. So just type it out in the comment box. I'll reply to that. Or also you could just DM me on any platform. I have linked them all in the description. Yeah. So I have now cloned the repo and seeded into it. Now I will open Tmux so that I can show nvim on one side and have the terminal access on the other. So source dash rc. Open. Yeah. So now what we have here is the backend. Then we have the app in Flutter, and we have the admin dashboard and the normal website dashboard for normal users written in Next. So what I'll do is first I'll explain the entire backend. Then we'll go on with the front end dashboards. There's not much to it, and then the app finally. So let's open the backend folder. Now CMD folder, this is where all the code required for the request and everything is there, and then in the internal we have all the configurations for database, for everything. Now let's first go into the data internal files, then we'll deal with the actual files. So this is just setting up the database. I have used a pgxpool library to set up a pool on my PostgreSQL. The I have a Postgres server running on my local machine. So this is just setting. So now we have the process webhook function. We have the update NSFW function. We have the support streamer function. So once we get into the code where we deal with it, I'll get back to this and explain this. So till then, let's go to the Discord and see what code it has. Yeah. So in this is just setting up a webhook to Discord to send uh, any errors or the logs at the end of the day. Or with this, we are actually catching the NSFW tips. So this is setting up the Discord webhook for that. This is just a standard. Now we'll go to the event bus. Yeah. So okay. So NATS. Now we are using NATS for communication within the microservices. So NATS is a distributed messaging service, just like Apache Kafka. It is a lightweight distribution service, so that was the reason I used it in my Go code. I could ship this as built into the binary of my existing code base. So that was the reason of selecting this NATS. Now in NATS we have the normal regular NATS and we have the NATS JetStream. NATS the normal or the regular NATs is at most once, and with NATS JetStream we can set up at least once, getting an acknowledge from every microservice, and until we get an acknowledgement, we just keep finding out the messages again and again. Yeah. So we have the NATS URL. I'll be running NATS in a Docker container. Then we have the regular NATS code. There's nothing in this to explain. We have the handlers. Handlers, yeah. Now this is the SSE or the server sent events handler. Now what is server sent events? When I was starting with this project, I didn't know about SSE. I was aware about WebSockets and was planning to set up WebSocket into it. But researching further, I found out that WebSocket uses its own WS protocol and it has a massive overhead. Whereas I could use SSE upon the regular HTTP 1.1 connection, so it was a huge plus point. Further, WebSockets are used when we need a two-way communication between the client and the server. But in my case, at most of the places, we just require a server streaming something to the client. So SSE was a good choice for that. So we have set up SSE for that. Now this is the regular SSE code. I won't be explaining this code. I would be explaining the code in the CMD directory. That is my custom code. Then we'll go along with streamer. Now this is the handlers. We have the structs defined. So now for the support stats are like, for example, if someone sets up a goal, like for example, support me to buy a PS5 or something. So we'll have the title over there. We'll have the total amount at this end, and then we'll have the completed amount based on how much tip they get. Then we have the response to the streamer. So I'll explain this when we call these functions. Then we have the get streamer function. Get streamer function basically takes in the streamer ID, and we return the name, we return the title, we return the total, and we return the completed stuff. Yeah. And then we have the setting up the response to the streamer. I'll explain this once we get into the code. This is again for struct for support request. It will have a support key, it will have a UPI ID, and it will have an issue. And this function, once again, I'll explain it. This is for creating the tips. This is a struct for tips. I'll keep this open. I'll get back to it. Now we have the logger. Logger is basically logging all our files. This is also the standard logging library. So nothing to explain over here. Into models. Yeah, this is the tip struct. The JSON response for our tip struct, and then we have the tip event, also the struct for tip event. Then we have the SSE on this side. Yeah, okay. So this is the SSE hub code. So what we do basically here is we have a client, we have a hub struct in which we have a client hash map that stores the active clients into it, and we have a heartbeat worker. The reason is because every when I was using it, every 125 seconds or so, the SSE connection was getting dropped for some reason. I just googled it and I found that you need a heartbeat for SSE. So I set up a heartbeat at every 15 seconds, so we can have a endless SSE. And we have here registering into the SSE and unregistering and the publish. So whenever our message gets pushed to the channel, then we return the message to our client. Okay. So now let's get into the interesting part. Okay, so this is the ingestion microservice. In the ingestion microservice, we have imported the Kai library. Then we have the Go away library. This is a what you can call a profanity checking library in Go. Then we have the NATS library for setting up NATS, obviously. Now we have a ingestion server struct. We have an incoming payload struct, and now this is the main function. We set up the NATS event bus here. We set up the server here, and we set up the router here. Yeah, handle webhook function. Now the handle webhook function is for handling the UPI confirmations from our app. So basically, what happens when we receive a payment or we receive a tip into our account, it pops up via Google Pay or Phone Pay on our phone as a notification. Our app reads that notification and it extracts a client key. I'll explain more about it later, and send it to our server. So now, when you're sending it, you have a bearer token that you are sending along with it. So now, if the bearer token is wrong, or we are getting just spam requests, then it will just go unauthorized. Otherwise, we'll update that, yeah, this so and so request, so and so tip has been paid. Now once this is paid, we publish to tips.processed the to our NATS stream, and then we go on ahead and we actually read the message, the content of the message. And if it is if it is profane, right here we are using the go away library to check if it's profane. And if it is profane, we update in the database that yes, it is nsfw, so it is not routed directly to our OBS client.